That's like the worst thing that could happen on stage to me, so I feel pretty good now. I want to talk about the Swift behind SwiftUI. And so if you start out with the SwiftUI template from Apple, you get something like this, and you run it, and you get something like this, and let's go to lunch now. So you want to figure out what's going on, and so you put in a print statement, and immediately you have an error. And I know you think the error is right here, that there shouldn't be a space between content view and the colon. But it turns out when you remove that, that doesn't fix the error. You still have this error, and you say, well, what is it? Okay, I'll read it. Ugh. So something about, there's a function, and you say a function, it's a computed property, but okay, I'll live with that. It declares an opaque return type, and I don't know what that is yet. It's a some view thing. It has no return statements. Well, it didn't used to have return statement. No return statements in its body. So why did it work when I didn't have a print statement, still no return, but now it doesn't? And of course, the key is Apple hates you. And I want you to know, not generically, specifically you, but let's go back and look at functions and closures. And so if we look at a function named multiply, and multiply wants you to enter two values in, and it's going to multiply them together because that's the name. And so it's going to return an int, and so we calculate the product, and the product is a times b, or whatever you passed in, and now we return that product. In this function multiply, that's how life works. But it turns out that multiply refers to sort of everything around it. And so we could rewrite this using let, and we could let multiply equal this. Well, this doesn't compile. We actually need to start a closure with a curly brace. And now this doesn't compile because the curly braces don't match. So we replace that with the keyword in. And now we're feeling pretty good. It compiles, it runs. It doesn't compile because you can't have external labels in closures. We've got to get rid of those two. Now it compiles, and now it runs. And now this multiply works exactly like the function multiply. But when we have closures, we like to be terse. And so when we have a closure, when we're using this let instead of this function, when we use this closure, we will tend to look and say, well, I don't need to create an explaining variable and return that same explaining variable. I'm going to keep myself from going to $0s and $1s. I'm just going to return a times b. And we're so excited because we remember if we have a closure with a single line in it, we can get rid of this return. And so we have this. And we write it on one line so we can say, look, I wrote it on one line. So I do this as a function. I have my function multiply. And again, I have this product and this product. And so I just return a times b. And you say, well, why do I have to have this return here in a function? I'd like to eliminate this return. And until now, you couldn't. But now, as of SE 255 being accepted into Swift 5.1, if you're running the iOS, the Xcode 11, you can now eliminate the return, and now we have a times b. And if you have a times b there, then that also works in functions that aren't functions, they're computed properties. And so your description, you can get rid of the return there and write it like this. And it looks horrible at first, but it's gonna grow on you. It will. All right, so let's go back here. I've got multiply and I've got product. What if I reintroduce my explaining variable? If I reintroduce my explaining variable, this breaks because it's only for a single expression function. And so I have to put the return back in. Goes back to Apple hates you. So why is this a single expression? It actually is addressed in there. So some languages say no matter how long your expression, the last line is what's returned. And Apple felt that that was a bit too much and was a little bit confusing. And so we go back to where we started, which was this view with a print statement and a text. And we see that when there's this print statement here, I need this return here. And now everything works as before. And if I remove the print statement, then I can remove the return, and that's why the template looked like that. Good? Okay, so implicit returns from single expression functions. The other thing that we got signaled about was this opaque return type. And the opaque return type is this some view thing. Some view. It's not just returning something that conforms to view. It's some view. It's that word that sort of throws us off. And so what we return has to conform to view, but it's something that conforms to view. It's got to be a concrete type. So here I'm returning text. And so the text is something that conforms to view. I could do it instead with an image, and this would be fine, because image conforms to view. And so let's have a hacking image, something like our logo here. And I force unwrapped it because I wasn't brought up right. If I get rid of force unwrapping it, maybe I have something like this that displays an image if it exists and a text if it doesn't exist. And so maybe I want to do this and say, look, if I if-let it, if it actually exists, then in the if clause, I want to display the image. And if it was nil, in the else clause, I'll display text. And it turns out this doesn't compile. And this doesn't compile for a couple reasons. The first has nothing to do with the opaque result type. It has to do with what we talked about before. An if statement is not an expression, and so I need returns, even though each one of these only has one. And so even though I've got this single line inside the if clause and the else clause, I have to insert my returns, and now that at least works. It's still not fixed. That would be too easy. But now we have an error message that we can read now that we've addressed one of those. And it says the function declares an opaque return type. That's this some view thing. But the return statements in the body don't match. I can't return an image and a text. And you say, why? They both conform to view. Yes, but some view says I'm going to return one type of view. Not one when you feel like an image and one when you feel like a text. They have to agree, and I return just one concrete view so the receiver knows what it's getting. And so this violates the opaque result type. And so those are two of the new things in Swift 5.1 that SwiftUI depends on. So let's go back to our image. And I've got my image, and isn't that pretty? You know where I got this image? Off of Paul's website. You can buy merch from him. So I've got this view, and it contains an image and some text. And you say, but Daniel, you said you had to have one type. You can't just throw in image and text. And so we wrap it inside this vertical stack, inside of this thing that organizes them. And the vertical stack can take as many things as you include because it takes many parameters, and it knows how to organize them. And so it includes an image, and it includes a text, and it displays them like this. I expected thunderous applause. But I look at this, and this isn't the Swift we were raised on. This is Swift that depends on function builders. Function builders is SE, it's not in evolution yet. So this code will change. So the code will change, so we won't spend a lot of time on it. But the idea kind of is, it's as if you had a UI or VStack, and you created and you passed it in the things you were creating it from. So you pass in the image, comma, and the text field. And this is not how it works. It's just sort of the idea of how it works from what you've done with, when you have a view controller and you add a subview and you add things to it. It's that type of idea. Or you might imagine it in code like this, where you create a VStack and then you add the image and then you add the text. So that's sort of, again, not how it works, but that's the idea behind function builders. And the idea is, let's give you a cleaner syntax. And so this is really nice. It's really clean. And in fact, VStack is taking something that instantiates a VStack, and this has just been moved outside as a trailing closure. And so you can see that you can include other things in there, but this is the trailing closure that says, this is my content, and it uses this view builder that returns the content that it's going to contain. And now if you want to go ahead and say, yeah, I want to say more about what this VStack contains. It contains an image, but I'd like it to be resizable, and here's the size I'd like it to be. For kicks, leave out the resizable and try to set the frame. Nothing. Or text, and you want to change the font to be headline for accessibility, and then you want to add a little space around it. This looks really nice from a top-level view. You can see it's a VStack that contains an image and a text, and then there's this customization and this making it look prettier inside there too. And so this is pretty readable. So this is from function builders. Again, it's still a pre-proposal. Things will change, and so that's sort of the thing I want to emphasize is the ideas are there. It's really nice right now, but the details will change. Okay, so let's look at an app, a running, working app that I spent like minutes on. So here's a slider with some results. I don't ask for much. And so inside of it, it's something like this. It's a VStack, and the VStack contains that text where it's displaying something, and it contains a slider that's adjusting things, and the slider goes from 0 to 10, and it goes by some ridiculous increment so that we see updates. But in UI views, in UI view controllers, we use outlets and actions, and so the slider could send a message to the label saying, update you. These things don't even have names. How do I tell the text view, here's what you display, and the slider, here's what you adjust? And the answer is, we have this state that says, look, store it here. I'm going to start out with the value 5, and you're going to adjust me. And so if I've got this value, I'm going to display the value in the text field, and I'm going to adjust it in the slider. And we use this $value for reasons that I'm not going to explain today. Oh, I will. And so I have this state, this var. And you think, okay, that's good. I'm displaying it in the text. I'm adjusting it in the slider. But how does this work? If I've got a struct and I'm changing the value, aren't I mutating the value? It's a struct. It shouldn't be that easy. And that's because there's something sneaky going on. And this is a property wrapper. And property wrappers are also new in Swift 5.1 and should have actually been approved by now. The third review just ended last week. And so this $value was called the wrapped value. It is now going to be called the projected value, and it's how that I can change this value underneath. And the state is using some magic to say, okay, this property doesn't really have the internal storage inside this struct. It's being stored somewhere else, and so we can have our struct and eat it too. So this example uses the current implementation, and it's not the final implementation, it's the one that you have in beta 3, so the details will change, but here's how you create a property wrapper. And so I'm going to create something that rounds the number to 2 places. And so it rounds to 2 places, and so I've got inside of this is the value I'm actually storing, this is the double, it is publicly readable, privately settable, and so if I'm setting it to 2 places, I've got this multiplier 100, and so what I'm basically going to do is when it's time for you to get at this wrapped value, this dollar thing, when it's time for you to get at the wrapped value, my getter just gives you the value, my setter takes the value, moves it over 2 places, rounds it off to the integer, moves it back 2 places, so I've rounded it off to 2 places. And now when you create a new instance of it, I say, you want to create a new instance of 1.2345, I say, well, that's fine, that's what you want to do. I'm going to round it off first before I store it. And so now, transparently from the outside to use this, I create this variable, this property, amount is 1.2345. I declare that it's going to be rounded to 2 places, and so when I create it, it starts its life as 1.234, and that's what we can print out. I'm sorry, 1.23 to 2 places. Counting is so hard. So using this was pretty cool, but here's something even cooler. And this is a technique, after I wrote this example, I read an article in NS Hipster, and he said, you know, we can do more. And he has a nice example for clamping that I'm going to adapt here to say, instead of saying I'm always going to round to 2 places, you can round to the number of spaces that you specify. You can tell me what your precision is. You can say round to 1 place, 2 places, 3 places. I'd go on, but you get it. My multiplier isn't going to be 100. My multiplier is going to depend on the precision, and so if it's 2 places, it's going to be 100. If it's 3 places, it's 1,000. It's 10 to that power. And so when I compute my wrapped value, it's exactly the same as before. The getter returns the value. The setter does the rounding for you. And now, when you create your new instance of a rounded to, you have to tell me 2 things. You have to tell me what that number is and what your precision is. And so it's 1.2345, and I'm going to round it to, say, 3 places. And so you're going to give me both pieces of information. I'm going to make sure that you're not out of your mind and you didn't tell me to round it to -4 places, because our users are horrible people and they'll do that. I'll set my precision. I'll round it to that precision, and here's how it looks like in use. This is what it looked like for 2 places. For rounding to any number of places, check this out. Isn't this cool? It's rounded to, and you specify the precision there, and then you set the amount. And so you set the amount just like you used to, and you pass in the other parameter here. That's pretty nice. And so now you get 1.235, because rounding. Okay. As Paul mentioned, I've got this obsession these days with map and flatMap, and you can't go anywhere right now, so I'm going to talk to you about them. So here's map with SwiftUI and Combine. Here's an app that I designed myself. And so I can set my mood. I can enter why I'm so happy. I can press enter, and now I can look at my history of what my mood's been lately, and I can look at details. And so to translate things, I'm going to use a view model. That's the part of this app I'm going to talk about. And so looking at one of these lines, you can see I've got my happy face, I've got my title about what I was doing, I've got the time and the date. And so the view requires these things. It requires an image, it requires text for title, text for the time, text for the date. But if you look at my model has an enum for the mood. My mood is an enum with joyous, happy, neutral, sad, and despondent as the values. The string is a title, so that's going to be easy to translate to another string. And I've got a date object, so I'm going to have to use a formatter of some type to pull out the time and the date as strings. And to do that, I'm going to use a view model, which the arrows obviously should go in the other direction. So my view model needs to know about the thing that it's modeling, and inside it just does the translation. So it takes a title to a title, it wants an image, so it reaches inside and it says, hey model, what's your mood? I'm going to transform it into an image, and for the time it says, look at your date, and transform the date using a formatter. And so now I get my strings and my images out of this. Now, how does map work? If I have a function that maps a single string to a single int, for instance, it takes cat and it counts the number of letters in it and it gets 3. I was going to ask you that, but I've given away the answer. Then I lift it to the map of f, and we say lift because we draw it on top. And so if we have an array of strings, a cat is dumb, then the map of f moves each one over, and I get an array of ints, 1, 3, 2, 4. And so what I have here is something that needs to be translated. I have a model, and I need to transform it into something the view understands. And fortunately, I have a function that does that. That was in this mood record model. I create a new view model from the model itself. And so if you give me a history, and the history contains an array of these model objects, and I want to display them on the screen, then in my view, I say, look, I bind to the history, so I get the history, and somehow I've got to turn that history's model array into view model array so I can fill this. And so we do this in a computed property for records. It says, I want to return view model array. So I start with my history, and I ask my history, hey, history, can you give me all of the model objects? And you say, I can, but I don't think that's what you want. The types don't match. And I don't know if your code talks to you. It says, just work with me here. And so we go back to draw a picture, and we say what I have is an array of my model objects. What I want is an array of my view model objects. And so what I need is some way of getting from one to the other. If only I had a function that could take a single model object to a single view model. You know, we always draw the bottom first and then the top, but that's not how we work. We're always working up here in these arrays and saying, well, I just need a single function that takes a single mood record to a single mood record view model, and that was this function. So there's my f. And so I can lift that f, I don't know why it animated that way, into the map of f. And so I just add the map to the end of this, and this is one place that we can use map in here. Now the types match, and now I can go ahead and fill my view. And so that's your favorite map in arrays, but you know there are maps in many different places in the Swift standard library. For example, there are maps for optionals. And so the map for optional works the same way. I have a function from string to int, and you give me an optional string, and so I lift that up as a map of f to an optional int. And so if you give me nil, a string optional, I transform it into a nil, an int optional. And if you give me some cat, I reach inside and I transform cat into the number 3, and now I've got some 3, which is int optional. And this is an idea from Erica Sadoun, which is just brilliant. And the idea is so cool. It says, if you have a VStack and you have an optional image and some text, then either the image is nil or it's not nil. If it is not nil, then it will get drawn. If it is nil, it won't get drawn. All of a sudden, you've got all this flexibility. And you say, Daniel, why do we care? I don't want to do all these if-lets. And this was a brilliant piece of insight. She said, what if I have this image and the image is optional? If the image is optional, then I can take that image and use the map for optionals. The map for optionals does what? It takes nil to nil. It takes non-nil to non-nil. And so I've started with an image, a specific image, and I've mapped it into a SwiftUI image container, and I only get something if the original image wasn't nil. And so if this thing isn't nil, if I go ahead and map this by initializing something from the image, and I resize it, and I show it, then I'll get this one if it's not nil. And if it turns out that this is no hacking, which I don't have an image for, I just get that. Isn't that the coolest thing? Now will you use map for optionals? All these years you said, no, it's not for me. Okay. Map from Combine. Oh my gosh, we haven't even thought about Combine yet. Daniel, what are you talking to us about? So I'm going to use the same examples they used in the presentations, and I'm going to show you map and flatMap from Combine. And so this was from session 722. And their example was you've got this wizard, and he's got a grade, and his name's Merlin, And the way Combine works is we have publishers and we have subscribers. And so we're going to create a graduation publisher, and the graduation publisher basically is doing what the notification center does. It's going to be the notification center, and it's going to publish, and it's going to use the default notification center. And what it's publishing is graduated for Merlin. And now I've got a subscriber. So this guy's sending out notification objects, and the subscriber is sitting around waiting for something to come in. And when the subscriber gets something, it's going to assign what it gets to Merlin's grade. But the problem is the publisher is sending out notifications, and the subscriber is waiting for ints. The types don't match. And when the types don't match, I can't do this. I can't say, hey, just subscribe to this thing you're giving out because you're giving me notifications. I want ints. And when the types don't match, something in your head is saying, ooh, map. So I have notifications being sent out. All I need is, if I want to lift this into the world of not arrays, right? Array generic and notifications, not optionals, notification, optional generic and notification, but in publishers. So this time I'm lifting up not into the world of arrays or notifications, but into a publisher generic and notifications. And so what map is going to do is it's basically going to sit here and receive a notification and then publish out an int. It's going to be both a subscriber to what it's getting from here and a publisher to what it's sending out. And what it does to transform in the middle is map. And you say, oh, that's the same map we know. And I say, yes. Map is a design pattern. Map is not something specific from arrays. And so here I am getting what I want. And so let me go back here. They've cleaned up the API as well, so instead of publisher with center default, I can change it to this. It's a notification center dot default, and I publish out these things. And then I map it. You give me a notification. I reach inside the user info dictionary. I pull out the grade, and if I can pull it out, I return it as an int. If I can't do that, I just say Merlin's in grade 0, and I laugh. And instead of this, once I've done that transformation, instead of this subscriber assign thing, we've got nicer notation for that as well. And so we can change this assign with Merlin and grade to this nicer call. And now you've got this nice chain of calls. And it depends on transforming it with map and then assigning it to the grade you want. Isn't that a great use of map? Oh, my last audience was so much better. Okay, let's look at flatMap. So you guys happy with flatMap? We love flatMap. Okay, so here's map. Map lifted a function from string to int to a function from an array of strings to an array of ints. And if instead I have a function from string to array of, I'm going to say array of ints even though it's an array of characters. Way to update those slides. And my function takes you from cat to an array of CAT, array of the characters in the string. And so if I get a cat is dumb, then map would lift you to an array of arrays. And that's clearly not what I want. I mean, I'm saddled with a dumb cat, and now I want these nested arrays. And so we flatten it, and we get a single array of all of the characters in all of the arrays. And so in Combine, where that comes up is, if you give me data, and I don't map you to a magic trip, but I map you to a publisher of a magic trip, then I'm going to use flatMap to transform from a publisher who's publishing data to a publisher who's publishing a magic trip. So, without flatMap, here's what's going on. My notification center is sending out these notifications saying, hey, there's a new trick for you, here's a new trick. Map says, okay, I can take that thing and I can release it as data, and you try to decode it. And you say, I've gotten data, I've got my JSON decoder, I've got a magic trick type somewhere, and the JSON decoder is going to take that JSON into the magic trick type. And if it works, I'm delighted. But something could go wrong. And so I have to catch. I have to look for an error. And so if there's an error, you're there subscribing for something. So if there's an error, I've got to give you something. And so what I'm going to give you is, I'm going to give you some magic trick placeholder. It's like giving out Merlin is in grade 0 if nothing works. I'm going to give you a magic trick placeholder, and I'm going to wrap it in a publisher, and I'm going to send it out. The problem is, this trick only works once. Once things have failed, once you hit your first magic trick that can't be decoded, you're no longer connected to the notification center. So the notification center is saying, hey, got a new trick, got a new trick. You're saying, I don't care. I sent out this placeholder trick, and then I just stopped listening. You know, those of you that are parents. So, I want to keep receiving notifications and decode them when I can, and when I can't, I'll send out this placeholder. And so that's where this comes out. What I want to do is not take data and not do anything with it, if you give me data, I'm going to return a new publisher no matter what, whether it's successful or it's not successful. And so what I'm going to do is I'm going to take data and I'm going to return a wrapper, a publisher around that data, and then decode it. And if anything goes wrong, then I'm going to return this wrapper around this placeholder. You go, well, that looks a lot like before. It does, except this time we're going to use flatMap. And so instead of just doing it once, we're going to do flatMap. So we're sitting here listening for notifications. If I can transform it, I return the publisher with that transformed data as a magic trick. It's a publisher of a magic trick. And if I can't transform it, I send out this default publisher, but I'm still listening, and the next time I get a successful one, so each time I'm doing the right thing and things are going through, and so flatMap, often we think of flatMap for recursion. Here's flatMap, we're just getting thing after thing after thing, and we don't want to stop. Whew. So we saw implicit returns, we saw opaque result types, we saw function builders, we saw property wrappers, and we saw examples of map and flatMap and SwiftUI and Combine, and now we get to see lunch. Thank you.